Now that we've explored vectors, it's time to move on to matrices. If you understand vectors, you're already halfway there. That's because matrices are essentially collections of vectors arranged in rows and columns. In R, a matrix is a two-dimensional data structure where all elements are of the same type, exactly like vectors. Think of it as a table made entirely of either numbers, characters, or logical values. To create a matrix, we use the matrix function. Before we do that, let's start with something familiar. Let's create a simple vector. We'll create a sequence of numbers from 1 to 12. We'll name our vector myNum. Now this vector, myNum, holds the numbers from 1 to 12. We'll use this vector to create our matrix. The matrix function takes three arguments. The first is the data, which in this case is myNum. It also takes the argument for the number of rows, which is nrow. This time, we'll make it 3 rows. And for ncol, we'll set it to 4 columns. This way, we've created a 3 by 4 matrix. I'm going to assign this to the object myMatrix. By default, R fills the matrix column-wise, meaning each column is filled from top to bottom before moving to the next column. That's why we see 1, 2, 3, then it jumps to 4 in column 2. These are the rows and these are the columns. Now we can change this default behavior by setting the argument by row to true. Oh, there's an error there. Now, if we check my matrix, we have 1, 2, 3 moving horizontally instead of vertically this time. Just like with vectors, we also access elements of matrices, but this time there's a difference. In vectors, we use square brackets. In matrices, we also use square brackets. However, matrices have special attributes called dimensions. We can check the dimension of a matrix using the dim function. This shows the dimension as 3, 4, with 3 being the number of rows and 4 being the number of columns. So, to access any particular element in a matrix, we need both values, a value for the row and a value for the column. We have to pass both into the square brackets. So, we have my matrix, then the square brackets. Let's say we want to access the number 7. For the rows, we have row 2 here. So that's 2, comma, and for the column, it's 3. Here we have it, 7. We can also access 12 here using my matrix with 3, 4. We can also access just one part, that is a single dimension. For example, I will access just a column. For that, I will leave the row empty with just a comma. Then the number of the column I want to access, which is 2 in this case. This returns 2, 6, 10. The same applies if I just want to access a single row and not a column. So this time I'll pass the row number first, since the first part is for the row, and the second, the one after the comma, is for the column. So I'm going to put 2 here for the second row, and I'll leave the column part empty, which implies return the second row and all the columns in the second row. And here we have 5, 6, 7, 8, just like we see. So this is similar to what we have in vectors, with a subtle difference. Given that matrices have 2 dimensions, I'll give you a short exercise to help us understand this a little. First, we'll create a vector of a sequence of numbers from 1 to 20, and then we'll create a 5 by 4 matrix from it. After that, you access the numbers 10, 11, and 15 separately. Then you also access the elements at row 3 and column 4, returning whatever element is there. And lastly, you access row 5 and return all the columns in that row. Don't worry, I'll include written instructions for this. Well, I hope that went well. I'm confident you will get this, but if you didn't, it's okay. Let's go through this together. The first thing we need to do is to create a sequence of numbers from 1 to 20. For that, I'll create a variable. I'll call this my sec and I'll pass 1 column 20. If we print my sec, we have 1 to 20. Of course, you can use the sequence function if you prefer. Next, we need to create a matrix object from my sec. I'll call it my secmat, or mat for short. For this, we use the matrix function. I pass the data my sec and I determine the number of rows, which in this case is 5. So it takes care of itself automatically. Next, we need to access the number 10, 11, and 15. To access 10, we pass my secmat. 10 is located here. That's row 5, column 2. This gives us 10. To access 11, we use my secmat, and that's row 1, column 3. Then lastly, we want to access 15. So we take the object, my secmat again, and 15 is row 5, column 3. So we can check for 11 and 15 like that. Next, we will get whatever value is present in row 3 and column 4 of my secmat. That's the number 18. Then lastly, all we have to do is return the values of all the elements in row 5. For this, we just put in the number 5, a comma, then leave a space for the column side to return all the elements. And we have 5, 10, 15, 20. I hope you got that. We can also perform some basic operations on matrices. I'll create a new section for that. Simple addition can be performed, and this can be element wise. What I mean by this is, let's look at my matrix. This is our first object, right? I can decide to add the number 10 to each of the elements of my matrix. And you see, we have 11, 12, 13. That's 10 plus 1, 10 plus 2, 10 plus 3, and all the way to 10 plus 12, which is 22. Another element-wise operation is subtraction. All the mathematical operation work element-wise with this. And you see we have minus, 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 up to 2, 1, yeah, which is 12 minus 10 and 11 minus 10. We can also add two matrices together. I'll create another matrix. This time, I'll first check the dimension of my matrix, and that's 3 by 4. So I'll call this my random. I'll use the rnum function to just create a random number of 12 numbers with a mean of 10 and a standard deviation of 1. So printing my random, we have this. But since I want us to have exactly the same figure as what I'm getting here, I'll set the seed to 1 to 3, and I'll run set seed again. So we have 9, 10, 12, and so on. Then I'll create a matrix from this, my rand matrix. If we check the dimension of my matrix, it's 3 by 4. So this will also be a 3 by 4 matrix. We can check the dimension of my rand matrix to confirm, and it is also 3 by 4. We can add these two matrices together. I have my matrix plus my rand matrix. Let's print them individually first, so we get a grasp of what's happening. So we have 1 plus 9 here, which is 10. We have 5 plus 10, which is 15, and 9 plus 12, which is 21. We also have 10 plus 12, which is 22. So they had themselves element-wise. The same also applies to all other mathematical operators, including the modulo and division. So we have my rand matrix divided by my matrix, and we have this. An interesting thing is we can nest this within the round function to round them up, say to the nearest two decimal places, and we have this nicely printed. My secmat is 5 by 4 and my matrix is 3 by 4, so we can't add these two together. We have an error here, and that's because matrices of unequal dimensions cannot be operated on together. I'm going to clear the console so we have more space and work again from the top. Instead, if you want to perform an operation where you can add more than one element to a matrix at the same time, it is better to have those values in a vector. I'll create a new object called my vec. I'll assign the values 3, 6, and 7 to my vec. Let's print out my secmat so we still remember what it looks like. It's a 5 by 4 matrix with 4 columns and 5 rows. So we take my secmat and add it to my vec. Let's see what happens. We get a warning. It says in my secmat plus my vec, longer object length is not a multiple of a shorter object length. I think that's a clear warning. But if we check the results, the output, we see that the operation has been carried out. Right here is my segmat, and this is the addition. Looking at the result of my vec, it's 3, 6, 7. So we have 3 plus 1, and that's 4. The way this works, the addition is done column-wise, not row-wise. So you have to be careful when you do this. You have 3 plus 1, which is 4, 6 plus 2, which is 8, 7 plus 3, which is 10. Then it starts again, meaning it recycles. Then back to 3 plus 4, 7, 6 plus 5, 11, 7 plus 6, and then back to 3 again. If we change the value of my vec, let's simply create a new vector. We'll call it my vec2. I'll make this just 1 to 5. Now, we add this to my segmat, so we have no warning. And it's easy to see that each of the elements of my vec2 has been added to each element of my segmat. An important attribute of a matrix that we haven't covered yet is its name. If we check the matrix function, we see that it has dim names as an argument. This is for passing the names of the dimensions, meaning the rows and the columns. But we can do this from here. We have my segmat, and we can decide to give my segmat column names. To do that, we use the colNames function. Here we pass the value. We just have to ensure that the number of values equals the number of columns. And for this, we have 4 columns. So I will give it the letter A to D. There's an object pre-installed in R, referred to as letters. So I will make use of that. Now, if you print my segmat, we have A, B, C, D. We can also do this for the rows using the function rowNames. Simply put the object in the parentheses, then we assign names. And this time, I'll use the lowercase alphabet. And I'm printing my segmat. We have A, B, C, D, E. If we don't want that, we can always change the names of my segmat. Now, I'll give it names, Michael, Dennis, Funke, and Foluke. And we have my segmat like this. I'll say that it is replaced. Now, back to operations in R. We can assume that my segmat is now like a class score. So we'll assign class score to my segmat. So we'll print class score. We have this result. These are the different scores of the student for particular subject like this. But now we have to make a change. Why this is nice, we need to ensure that the rows becomes columns and the columns become rows. What I'm trying to say is Michael, Dennis, Funke, and Foluke should become the rows, while A, B, C, D, E become the columns. There's an easy way to do that. Instead of recreating these from scratch, we can use the transpose function, which is represented by T. So T, then pass in the object class score. We have it like this. Now that we've transposed that, I'm going to assign this to class score transposed. And we'll use class score transposed. Next, we have to change the column names to actual subjects. Now this is the new phase of class score. We can decide to get the average score of each of the subjects. There's a function to do that called colMeans. We pass colMeans and then pass the object into that, which is class score transposed. We now have the average for each of the subjects. It's 0.5, 9.5, 10.5, and 12.5. It seems the students aren't doing well in mathematics. We can also decide to get the average of each student using rowMeans. These are some of the operations you can perform on matrices. Next up, I'll introduce you to 2 other useful functions. But before that, let's take a short exercise. In this exercise, we are going to create a matrix of students with 3 test scores. You arrange the test scores in the columns and the student names in the rows. Also, you'll find the average of each individual student score, and you'll find the average of each individual test scores across all students. This will help you see which test they perform best in. Not to worry, I'm going to give you the values here. Simply follow the instructions and you should get exactly the same results. Well, I hope that went well. Now let's do this together. First, we need to set seed and set it to 1, 2, 3. Then we need to create a vector of scores with 9 elements of random numbers with a mean of 70 and a standard deviation of 20. And we should assign this to the variable scores. Next, we have to create a 3 by 3 matrix by row with the variable name student score. But before that, let's print out scores. So this is what we have. Now for the matrix, give it the name student score and create a matrix. We pass the object scores with the number of rows set to 3, and we have to arrange it by row. I hope you didn't forget the argument by row. We set by row equals to true. So you should have this as your student score. If you don't have this, it's okay. The main idea is to be able to follow the concept and get the results using the right functions for each task. Next, we should change the column names. So set the column names of student score, change it to test 1, test 2, test 3. So I'll simply copy this and I'll paste that here. It reads, so for student score, we have student score now. We have test 1, test 2, test 3 as column names. We also assign the names Ahmed, Clara, and Shombe to students. That means we should change the row names of student score. I will insert these values here, and now we have student score. So we have the student names and their test scores. Next, find the average student score and which student performed the most. The average student score. So what we need now is to get the mean row-wise, since we are interested in the students and their scores. So that will be rowMeans. I'll pass in the object student score, and we have Ahmed 75, Clara 82.76, and Shombe 60.06. So which student performed the best? That's Clara with 82%. Next, find the average test score. So we see which of the tests the student performed the most, and that will be colMeans. Now, test 1 averaged 69, test 2 averaged 60, and test 3, they did really well, really well, with 87. So they performed the best in test 3. I hope that was clear. If you don't grasp all the concept right away, there's no problem. Always revisit this, watch it multiple times, and ensure that you master the functions and understand the idea behind what you are trying to achieve here. Now, the last part we'll be covering is adding more rows and adding more columns to the matrix. Before we proceed, I'm going to clear the console again, so we have a fresh screen. Okay, now let's take my segment as an example. And we have 4 columns and 5 rows. I'll simply check the dimensions, dim my segment. It's a 5 by 4 matrix. So if I decide to add new values to my segment, let's take numbers 1 to 4 to create a matrix from 1 to 4. Its nrow equals 4. Oh, actually 4. So we'll make this 1 to 4 as our number of rows is equal to 4. I'll call this my mat2. Now to combine my segment and my mat2, we need the number of columns for both my segment and my mat2 to be the same. We combine this using the function rbind. With rbind, we take the object separated by commas. Since we have an error, it says in rbind, number of columns of matrices must match. That's true. My segment is 5 by 4 and my mat2 is 4 by 1. So instead of nrow, it should be ncol. Ncol equals to 1. This is one of the subtle errors we sometimes make. Thankfully, we have clear error messages that really help us pinpoint where we have gone wrong. So now we bind. And here's the result. We can also change the row names here if we want. We'd simply assign it to a variable, then go in and specifically change those row names. Now, when working with columns, it's crucial that the objects we want to combine have the exact same number of rows. Let's call this one my mat3. We have a matrix from 1 to 5 with nrow equal to 5. And if you print my math tree, you'll see this. For this, we'll use the cbind function. Just as rbind is for row binding, cbind is for column binding. So using cbind, we'll take our objects, my secmat and my math3, and here we'll have it. An interesting thing is that you can actually include the dimensions name for my math tree. But I'll leave that for you to research on your own. Simply head over to Google and look up how to use dim names in a matrix. Or you can just go to the R console, type a question mark followed by matrix, and you'll see examples of how dim names are used. Well, that concludes this lesson. I'll see you in the next one where we'll dive into data frames.